Hello students, today we continue our lecture on thermodynamics. We have already completed first two lectures of thermodynamics. In this lecture we are going to deal with the Gibbs free energy and requirement to be a spontaneous reaction or non-spontaneous reaction. So this lecture is presented by me, Pranit Ghatak, your chemistry teacher. So let's begin. Here, as the first topic of this lecture is Gibbs free energy. So, what is Gibbs free energy? This del G naught, this delta G naught, this 0 means naught. Okay, so this delta G naught is being called as Gibbs free energy. Gibbs free energy is the energy that is available to do useful work. Okay, so it is the available free energy. Available free energy is being called as Gibbs free energy. Okay, and this is the parameter by which we can know if a reaction will be spontaneous or not. In the last videos we have discussed about what is spontaneous reaction and what is non-spontaneous reaction. So spontaneous reaction are them or those which occur by themselves. They do not require any external help. But in the case of non-spontaneous reaction, they cannot occur naturally by themselves. They need assistance from external source. Okay, so if a reaction is spontaneous, then the reaction will go on naturally. If the reaction is not spontaneous or non-spontaneous, that reaction will not occur naturally at all. Okay, here in the case of Gibbs free energy, this parameter gives us an idea about if a reaction is spontaneous or not. If the reaction is spontaneous, then del G will be negative. Okay. If the reaction is not spontaneous, then del G naught will be positive. Okay. So del G naught is basically a free energy that helps us to understand which reaction will be spontaneous and which reaction will not be a spontaneous reaction. And this is the account for the available free energy to do some useful work. Okay, if the delta G naught is less than 0, that means it's negative, then it will be a spontaneous reaction. If del G naught is greater than 0, then the reaction will not happen. That means the reaction will be non-spontaneous. If the reaction is less than 0, that means negative. Then if the delta G is negative, then it will be a spontaneous reaction. Okay, and we have a equation by which we can find out the value of delta G naught, that is Gibbs free energy. Okay, so here in the case of this equation, we need a equation. This is this equation. The equation tells us that delta G naught is equal to delta H naught minus T delta S naught. Okay, or we can easily write it as, del G is equal to del H minus T del S, where del G is equal to Gibbs free energy, del H is enthalpy, and T is temperature, and S is entropy, and del S means change in entropy, del H means change in enthalpy. Okay, so basically del G is equal to del H minus T delta S. This is the requisite equation by which we can easily calculate the value of delta G, that is Gibbs free energy. I am repeating myself. If the delta G is negative, then it will be spontaneous reaction. If delta G is positive, then it will be a non-spontaneous reaction. Okay, so here this what is being written on the slide as well. If the delta G is negative, then it will be a spontaneous. If the delta G is positive, then it is non-spontaneous reaction. Okay, and if the delta G is equal to 0, that means the reaction is in equilibrium. Okay, and in the next chapter is being called as equilibrium. The equilibrium is of two types, that is a chemical equilibrium and ionic equilibrium. In that chapter we're going to deal with the what is equilibrium and the parameters of the equilibrium as well. Okay, so please remember up to now that if the delta G is negative, then it will be a spontaneous reaction. If delta G is positive, then it will be a non-spontaneous reaction, and if the delta G naught is equal to 0, then it will be the reaction is at equilibrium. Okay, and by this equation we can have some idea about which are the reactions that may have been having a negative value of delta G. That means it can be a spontaneous reaction, and if the value is positive, then it will be a non-spontaneous reaction. But to do that, we need to calculate the values of del H as well as T delta S. Okay, so here I have given a chart in this slide that if which is the values of del S and del G and del H, if the values of del H and del S changes time to time, and we will have 4 parameters by which 4 equation or 4 conditions that show del G will be positive or not. Okay, so let's do the calculations here. So our requisite, what happening, the equation is basically del G is equal to del H minus T delta S. If del H is negative, condition number 1, if del H is negative and as well as del S is both negative, then what will happen? If del H is negative and del S is also negative, or del S is positive, suppose del S is positive, what will happen? Okay, if del H is negative and del S is positive, then what will happen? If del S is positive, that means T del S is positive, but here the whole thing, the T del S is also positive. If del S is positive, and T del S will be positive, but here there is a negative sign, so there will be negative and there will be positive. That means a negative will be there. So total this term will be negative. So minus T del S. So minus T del S. This total term will be, this minus T del S will be negative. So as it is negative and del H is also negative, so both the terms is negative. So del H, del G will be negative. So in the case of if del H and del S both, if del H is negative and del S is positive, then del G becomes negative, and if del G is negative, then reaction will go on. It will be a spontaneous reaction. Okay, I am repeating myself. What happened when del H is negative and delta S is positive? That means T delta S is positive and there is a minus before it, so minus T delta S will be negative. As minus T delta S will be negative, so what happened? Del H is also negative and minus T del S also negative, so del G become negative and it will be a spontaneous reaction. Okay, and let's suppose del H is negative, del H is negative and del S is positive, then what will happen? Okay, so in that case, what happened? Yes. In that case, del H is negative, but T del S, that is T delta S, will be negative because del S is negative. As del S is negative, T del S will be also negative because temperature cannot be a negative. Temperature is always be a positive. So T is positive and del S is negative. So plus and minus, that when it multiplies, it will form negative or minus. Plus and minus, that gives us minus. So T del S will be negative, and before T del S there is a negative sign to it, and this negative, when multiplied with this negative, it will become a positive sign. So minus T del S will be positive and delta H will be negative. So here there is a condition number 2 where if delta H is greater than delta S or T delta S, then it will be a negative because del H is negative and T delta S is positive. Minus T delta S is positive. So if delta H is greater than T delta S, then it will be negative. Del G will be negative and the reaction will be going on. The reaction will be spontaneous. If delta H, that is the negative quantity, is less than minus T delta S, that means the positive sign here, del H is negative and minus T delta S is positive. So if minus T delta S is greater than del H, then it will be a positive value of del G. And as we know that if the del G is positive, then the reaction will be non-spontaneous. Okay. So here remember, here in the case of if del H is negative and del S is positive, that means T del S is also positive because temperature is positive. Temperature is also always be a positive term, and as T delta is positive, so minus T delta S will be negative. And sorry, repeat. I'm doing a mistake right now. So what happened if del S is positive, then T del S is positive, and if T del S is positive, so the minus T del S will be negative, and minus T del S and del H is also minus, so that will be a negative as a whole. For the that is why the del H will be, so del G will be negative and reaction will go on. But if in the case of del S is negative, if del S is negative, so what happen if del S is negative, T del S will be negative and minus to that, so minus T del S will be positive. If minus del S is positive and del H is negative, so that depends on the power to that. If del H is negative and minus del S is positive, if del H is greater than minus T delta S, here in the case, then reaction will go on because delta H, delta G will be negative. But here if the case of second term, that is here in the case, if del H is less than minus T delta S, then minus T delta S is a positive quantity, and minus T delta S is a positive, as it is a positive quantity, if it overcomes the value of del G, del H, that is a negative quantity, so positive quantity will overpower the negative quantity and delta G value will be positive. As the delta G value will be positive, so the reaction will not be spontaneous. Okay, and so let's move to the third condition, where as we know del G is equal to del H minus T del S, where del H is positive and del S is also positive. So what happened if del S is positive, then T del S is positive, but minus T del S, that is T del S is positive, but minus T del S will be negative. Minus T del S is negative and del H is positive. So here if del H is greater than, minus T del S, then the positive quantity overcomes the negative quantity and the del G value will be positive and reaction will not occur. But here if the del H value, that is the positive quantity, is being overshadowed by the negative quantity, that is minus T del S, if minus T del S is greater than the del H, then the negative value overcomes the positive value and it will be negative. The value of del G will be negative and the reaction will go on. So this is the condition number 3, and let's move to the last condition, that is where del H is positive and del S is negative. If del S is negative, so that means T del S is also negative. But as we know that minus T del S, negative into negative, this is minus and this minus into this minus, so minus into minus, that means positive. So T del minus T del S is all positive, and as delta H is also positive, so 2 positive plus and plus plus, that means all of these are total term, that is del G value will be a positive one. As del G value is a positive one, so that means the reaction will not occur naturally, so the reaction will be non-spontaneous. So in this 4 condition we can have the spontaneous or non-spontaneous equations, okay, by applying this del G is equal to del H minus T delta S, this equation. Okay, so this equation is very much important, and by calculating each and every factor we can tell about a reaction is spontaneous or not. What I have explained in that slide, and this is quite explained in the slide as well, so please go through it properly. And in this lecture I have completed all the portions of thermodynamics, starting from the system, surrounding, and then first law, enthalpy, entropy, and right now Gibbs free energy. Okay, and right now we can also predict the reaction as a if it is spontaneous or not. Okay, so I hope you have understood this part very well. If you have any kind of doubt, please ask me in the comment section below. So thank you very much. Bye.